Hello and welcome to Mystery Science. You're joining us for the final lesson in our energy in the home topic. Those of my students who are following along from my college will have booklets to be working from, and if you're joining us after lockdown or from a different college, then feel free to follow along. Anything I ask you to write down, just write it down on a piece of paper. So this lesson, we're looking at renewable energy sources. Last lesson, we looked at resources that were non-renewable. This lesson, we're looking at renewable resources. So we're going to look at what that means, what the difference between renewable and non-renewable is, and we're going to give examples. So our do now, the thing we do right at the beginning, is to name 4 non-renewable energy resources. What is meant by the word finite, and then give a disadvantage of using fossil fuels to provide energy. So pause the video, have a go at those, and come back in a moment. Welcome back. So for non-renewable energy resources, coal, natural gas, crude oil, and nuclear like uranium and plutonium. Finite means that there is a fixed amount of something. It's going to run out at some point. And non-renewable means that we're using the fuel faster than it can be replaced. Fossil fuels take millions of years to turn into fossil fuels, and nuclear sources are natural rocks that just won't be replaced. So a disadvantage of using fossil fuels is that eventually we're going to run out of them. Another disadvantage is that the burning of fossil fuels creates greenhouse gases, which is one of the leading causes of climate change. Okay, so what about renewable resources? We know that non-renewable sources are things like coal, natural gas, crude oil, and nuclear power sources. So renewable energy sources are things like the sun. Most of the energy, in fact, all of the energy on the planet does come from the sun. Water, biomass, which is things like trees and wood, wind, and volcanic heat. These are all great resources to create energy instead of using fossil fuels. So what is renewable energy? What does it mean? Well, renewable energy resources are resources that are being used at the same rate that they can be replaced. They're not finite. There's an unlimited amount of them, so they won't run out. They're infinite. So for example, the wind will just keep blowing. As long as there is weather patterns on the earth, then the wind will continue as it is. Okay, so here's a little quiz. If you're following along with the booklet, there is actually a space in the booklet to put your quiz score. So which of these is not a renewable energy resource? The sun, biomass, wind, or nuclear? And the answer is, of course, nuclear. Nuclear comes from radioactive rocks. What word does this statement define? Used at the same rate as they can be replaced. Renewable, non-renewable, finite, or not finite? Of course the answer is renewable. Renewable means that as you're using something, it's being replaced at exactly the same rate. So while you're using it, there's more of it coming. Brilliant. It doesn't go anywhere. So if there's an unlimited amount of something, so it won't run out, is that renewable, non-renewable, finite, or not finite? Or infinite, as would be better. And that's right, it's infinite. If it's unlimited, it's not going to run out. That's the definition of something that is infinite. It's never going to run out. There will always be tidal currents. There will always be the wind. The sun will always be there. And by the time any of these things are disrupted and stop working, we won't care about it anymore. By the time the sun stops working, we'll be long gone from the planet, one hopes. Okay, so here are some independent questions for you. Could you please name 5 renewable energy resources? Tell me what renewable means, and then tell me what not finite or infinite means. So the 5 renewable energy resources are, of course, sun, water, wind, biomass, and hot volcanic rocks. This is geothermal energy. So what does renewable mean? Renewable means that it's being used at the same rate as it can be replaced, which leads on to infinite or not finite, meaning there's an unlimited amount of something. It will never run out. Let's look at examples of how we can use these renewable resources to turn that into fuel for us. Okay, so our first example is the sun, solar energy. Now, there are different ways that we can use solar energy. We have things that are called photovoltaic cells, and that's what these are. Now, photovoltaic cells take energy from the sun and they turn that directly into electricity. So you can use entire fields of these photovoltaic cells to take the energy from the sun and transfer those into electricity. You can see these on the roofs of some buildings. So the school that's across the road from me, the primary school, has these photovoltaic cells across their roof, and that provides some of their electricity. Driving towards Bristol on the M5, you can see fields with these solar panels facing the sun and generating some electricity as well. Now, as well as this, we can use the sun as a heat source to boil water and use that to drive turbines. So fossil fuels, the way they work is you burn the fossil fuel and we use that to boil water, and the steam is then used to drive a turbine. You can do the same thing with solar energy, but only really in hot countries. In kind of mid and south Spain, they have these massive solar arrays, which are literally just mirrors that are angled up towards to the top of a tower. At the top of that tower is a massive tank of water. The solar array reflects the sunlight onto this tank of water, which boils the water. It's so hot, it's so focused that it boils the water, creates steam, and drives a turbine the same way the fossil fuels do. Water can be used in so many different ways to create electricity. Water will flow, and it flows from a high ground to a low ground. Also, if you use a dam and collect lots of water, it builds up lots of pressure. So you can use this pressure to create a hydroelectric effect. Again, if you have a dam and the water comes on and gets stuck and it wants to flow through the dam, what you do is you allow some of it through under high pressure. That water under high pressure again drives turbines. That turbine driving creates electricity. And you can also do this with tides. These tides literally take the force of the tides going up and down to generate electricity, and the same with waves. You can have these great big long strip pontoons that as the waves on the water come in, they generate electricity, again using this up and down motion. Biomass. Biomass is anything that is alive being used to create energy. So here is a biomass energy power station. So if you use coal, coal is a fossil fuel. It's something that has been alive once before and has been crushed under high pressure and turned into coal and then burnt. You can do this with wood. Sure, if you chop down a tree, it was alive and you've killed it. And even if you use felled trees, it's dead now. But you can plant trees, and you can plant trees so that they grow at the rate at which you're cutting them down. So they do this for paper mills. They have huge areas of land, and they will cut down a section of the trees, and they'll use it to create paper. And in this case, they'll use it to generate power. And while they're doing that, they're planting more trees in the different space, and they normally plant just a bit more than they've cut down. And then they'll move on to another section. And while they're cutting at a different section, this first section is growing. And so they keep doing this. And by the time they get back to the first section they've used, the trees are large enough to be cut down and used again for energy in the power station. And so every time they cut down a field, they're planting more trees. So we're getting more and more biomass to be used in this endless cycle. Now this relies on those crops and those trees growing at a specific rate. One of the other types of biomass is poo. Poo rots. When you get lots and lots of manure and put it in one area, it will create what we call biogas. It will create the natural gas, which we can then burn or keep under high pressure to create this turbine driving. So you can get biomass from different places. You can even grow other crops, faster growing crops like wheat, and turn that into biofuels. Living in Devon and Cornwall, we're quite familiar with the sight of the odd wind turbine here and there. This is used for the wind driving across the land, and the wind turbines are then pushed by the wind. They rotate and generate electricity in exactly the same way as in a normal power station where steam is driven through a turbine. The only trouble with the wind turbine is, of course, they're not as predictable. It's not always windy. It's often windy, but sometimes it's too windy and the wind turbines would turn too fast. So not always as useful as they might seem. This last example is an example where we can harness the power of geothermal energy. Now, geothermal energy is something that's easy to access in places close to the edge of a tectonic plate. We talked about tectonic plates before in Earth and atmosphere, and so the geothermal energy stations, places like Iceland and Norway, have quite a lot of geothermal energy. It's quite warm under the ground. The crust is quite thin there. You pump cold water down into the rock, and then you move that through pipes, and that gets hotter as it gets close to the volcanic heat. That hot water is then used to drive a turbine, just as it was in the fossil fuel station. But now we're just pumping water through the ground, and that is naturally heating it. Obviously, the dangers of this is it's quite near some volcanic activity, and at any point this whole volcano area could kind of erupt and cause a natural disaster. But then that's going to happen in these places anyway. Okay, your final task in this video is an extended writing task. If you're following along in the booklet, there's a large space for you to do this. I want you to imagine you're a journalist for a scientific magazine like New Scientist or Life magazine. You've been asked to write a piece of work explaining the difference between renewable and non-renewable energy resources. In your writing, you should include definitions of both renewable and non-renewable, what they both mean and what the differences are. Give examples of both and research the advantages and disadvantages of each type of energy source that you use. That should take you roughly, again, 15 to 20 minutes. Right, that is the end of our energy at home section. So well done, stay safe, I'll see you soon.